Hi, today we're going to look at our review for the Solid Modeling Manufacturing Process and Design 2203 midterm exam. In this exam, you'll be expected to create a part, actually in this case two parts. You'll model what's called a rear casting, and then also model a gasket that's attached, as well as create an assembly of this gearbox that you'll see in a moment, and then we'll make an exploded view drawing of it with the balloons and bills of material. So let's begin. First of all, let's take a look at the drawings. This is the drawing that you're going to have to recreate. It's an A-size drawing, and it's just going to have an exploded view with balloons attached to the part and also a relevant bill of materials attached. Make sure your name's on it as well. Here are some additional drawings of this. The first drawing you'll see here is this one, and actually this gives you the raw data for constructing the model. There are a couple dimensions that are missing, so I will try and show those to you right now if I haven't updated the actual document before the midterm. Okay, as we can see here, we have the rear casting. It's going to be about 3.5 inches diameter at the bottom, so on. We actually don't really need a whole lot of these dimensions because I'm going to show you how to use the top-down assembly method inside SolidWorks. And we've gone through this before. It's a little tricky, but this is all a review, so let's take a look. We begin by going to File, New, and select an assembly. When you have the assembly open, be sure to do a couple things. First of all, cancel out of this begin assembly mode right here by hitting the little X at the top left. Now we could go into the tools options and make sure that we have the proper settings for it. First of all, under document properties, it should be set to ANSI. The units should be set to IPS, inch, pound, second, and technically 3 decimal places is a good idea to have it set to. So now once we have that, we could go ahead and save it. So let's go ahead and click on Save, and save this as your MT for midterm 2203. Now, one other thing we might want to do is bring up the origin. By default, it's turned off, so let's turn it on. Go to View up at the very top, go to Origins, and you'll see it. Now we're in our assembly, and we could go ahead and drop in some of the components that are already built for us. So we go to Insert Components, hit Browse, and then search for your Manufacturing 2203 folder, Sample Files, and Midterm. Once there, make sure that under Files of Type that it's set to Part File. And now you could select what you'd like to bring in. In this case, let's bring in the front casting. Select the front casting, hit OK, and drop it in on the origin by clicking with the tip of your pointer on the blue origin. That will lock it in for us. Okay, the next thing we need to do is we're going to go ahead and insert some of the other components as well and start assembling this. So again, go to Insert Components, go to Browse, and let's go ahead and find the bearing. Go ahead and select the bearing, and when you select it, you'll see over to the right there's an option for 1 inch or 0.5 or half inch bearing. We actually want 3 1-inch bearings and 1.5 bearing. But let's bring in just, a 0.5 bearing. Let's go ahead and just bring in the 1 inch and just drop it anywhere by clicking. Instead of going back and going to Insert Components, here's an easier way. Just hold the Control key down and grab the part that you want to make a copy of with the left mouse button. Hold the left mouse button down and drag as you're still holding on the Control key. The first thing you want to release is the mouse button. Then you could release Control, and you have a copy. Let's do it again. And once more. Okay, now we have 4. Now to change one of them to a 0.5 inch bearing, just right click on any one that you want, and you will find a Configure Component. With the Configure Component, hit this little arrow here, and you'll see the 0.5 is an option. Hit OK. And now you have the 0.5. Let's go ahead and drop the 0.5 in place. We'll go to the mate tool here, the little paper clip, select the face of the bearing. It could be the inside face or outside. Now you can see this is a little challenging to try and select these entities here. It might be a good idea to activate the selection filter. And the way we could do that is a simple right click, mouse button click on any of the gray area up here and find the tool, which is okay, so a simple right click and look for selection filter. It's alphabetic. Select selection filter. It should appear maybe at the top or the bottom, wherever it appears. What you're looking to is filter faces. The X key actually on your keyboard will turn this on, but it's a good idea to turn the toolbar on so you could select other options as well. So we'll go ahead and select this face here and this face and apply it. Okay. The next thing we could do actually is we could select the underside face of this. If it's difficult to rotate and see it, you could drag it up and then rotate, get the underside face, select that, and rotate it down and select this face. There are other ways of doing that. A simple right click on the surface will give you a select other option as well. Now let's get the bearing over here. So again, we'll select this face to that face, and then the bearing should be flush with the surface. So this face to that face. Okay, before we put the other bearings in, we have to bring in the gears. So the next step, go back to Insert Component, go to Browse, and go ahead and bring in the this component, the pinion, and hit Open, and drop that up here. Again, we'll go back to the mate, select this face to align it, drag it up, select this bottom face, and rotate it around and select this face down here, so they go coincident. Hit Apply. Go back to Insert Component, browse again, and find the spur gear. Hit Open, and drop that right over here. Once again, click on the mate, paperclip, select this face and the inside face of the bearing, hit Apply, and then select this face to this face. Now you'll see if we rotate this, they're not actually truly meshing, and nor will these. These are not real gears. I just threw these together very quickly one day. So they're a little bit larger than they should be, and they would actually not work correctly. But they're somewhat close. For a visual, we could see that try and move them together just by holding the left mouse button down and dragging one of the parts. And what we're going to do is we're going to apply a gear simulation mate, or just a gear mate. So on the left hand side with the paperclip still selected, go to Mechanical Mates and you will find Gear. Select the shafts of the two entities. Select the pinion first, and then go ahead and select the spur gear. Now you'll see teeth diameter and options here. Under ratio, why don't we just go ahead and type in the ratio. What the ratio is just the number of teeth on each one. So the first one was 19 teeth, the second one has 24 teeth. And hit Apply. Hit Apply again, and you can run a test just by grabbing one and dragging it. And it should simulate as if they're truly meshing. Okay, let's get the other components attached. Now we'll go ahead and select Mate once again. Select this face here to this face and apply it. Now if this happens where it's buried inside there, you may have to go to a wireframe mode. That's up here. Click on this little icon here, find wireframe, and then we could see it right here. Grab an edge. Now right now you'll see it's difficult for me to grab an edge. That's because I still have the selection filter on. To deactivate the selection filter, just simply click on this little option, or F6 on the keyboard. Grab the edge of the part you want, drag it up, and then you could return back to your previous state. Okay, we could go back to turning on filter faces, and we'll go ahead and just select, oh, I got an edge, let me clear that. this face to that face. Let's attach the next one. Select this to that. And then this little face here to this face. As a matter of fact, actually, one of these is not going to align properly. Actually, both, there's a little problem. There is actually an interference between this model here, but that's okay. You could leave that alone. Fix it. I used to give extra credit if people would fix it, but I no longer do that. But whereas I just added this one, let's go ahead and undo that and leave that one floating for right now, so it could be moved around because this is going to stick out of the back. This one might actually too. Oh no, never mind. We're good with that. Okay, let's go ahead and save what we have. You'll get a little message. Just hit yes. The next step is we have to go ahead and create the actual gasket on here. All you do for that is you go to Insert Components, the little arrow at the bottom, and we select New Part because the gasket is not made for you in advance. Now with this new part, we just simply have to take a look at our pointer. We have a little check mark to the right. This is an indication that SolidWorks is waiting for you to apply a face or plane or location where you want to drop your new part. We want to drop it right on this face because that's where we're going to start sketching right away. So I just click on it with the left mouse button. I'm already in a sketch mode because it does that automatically when you're working top-down assembly. We'll go ahead and select this face. Go to Convert Entities. Now select with the right mouse button one of the inside edges and select Tangency. That will select the whole inner rim. And go ahead and hit Convert Entities once again. Now you have an inside and outside nested geometry. For some reason this went ahead and wants to save this. That's okay. I'll just hit yes. I'm going to go ahead and save this. Actually, we'll save that in a moment. Let's grab the holes now. To grab the holes, just simply hold Control and select each one with the left mouse button. Once selected, hit Convert Entities once again. Now we're free to extrude this. So if we go to Features over on the top left here, find Extrude Boss, and the thickness is supposed to be 30 thousandths of an inch, so 0.03. To be on the safe side, maybe type in IN to make sure we're working in inches because some of the systems at school are set up in metric by default, and we never set up this part file specifically to be metric or inches, so it might be defaulting to metric, so it's not a bad idea to do that. Alright, and there is our gasket. It's finished. So what we want to do now is go to File, Save As, and it's going to give you two options to resolve ambiguity. If you select the bottom option, that will save the entire assembly as well as the part. If you select the top option here, it will save only the part. Let's do that. Let's hit OK. It's going to give you an option here. Just hit OK again. And let's call this the gasket. And hit Save. Alright, our gasket is finished and we've renamed it properly. Now we could go ahead and get out of editing that component. This is a very important step. Simply do that by selecting the Edit Component button, which will deactivate our part from being worked on at the time. Another good thing maybe is to turn off the toggle selection filters. We no longer need that. Okay, now we could go ahead and start building our second part. So we go to Insert Component, New Part, once again, and we want to drop it on the surface of the gasket. So just click similar place where you selected last time, and we're starting to sketch right away again. Now let's select this face and convert it once again because it's the exact same size that we need for our rear casting. Don't select the inside though, because all we want is the outside here. And don't worry about the holes. Actually, we could select the holes right now if we like. Let's go ahead and do that. Hold Control and select each hole, at least the edges of the hole. Now hit Convert Entities. Now we just have to extrude this. But let's take a look at our document first. Let's see how deep we have to extrude this. Okay, from that base surface, it's going to be 0.25 thick. So let's go ahead and go to Features, Extrude Boss, 0.25, and hit Apply. There are callouts on the print for draft, 1 degree typical. You do not have to add those. I took that off the test. So, but if you want to give it a try, go ahead and you could add draft while you're extruding, and the dimensions that appear on some of the prints will be more relevant than they are if you don't add draft. Anyhow, let's go ahead and move on here. I'm going to turn on my filter faces here so I could select this whole face. Actually, here's a little trick. We want to select the underside face. Just simply right click on the surface and you'll find an option, Select Other. Go ahead and select that. What it does is it selects the face behind the top face, and you could actually move over the surfaces until you locate the one that you want. In this case, the one that we're seeing there lit up in yellow is the base surface. Let's go ahead and select that and start our sketch on it. The reason why I'm doing this is to eliminate the possibility of an error, especially in a midterm exam. You don't want to have something the wrong height or dimension, as it will be marked off. So by doing this, the print, you'll notice, is labeled as such from a baseline, therefore eliminating the need to do any sort of math, even though these are very simple minus subtraction problems. But in this case, from that base 0, we could go ahead and extrude it 1.120. So now we just, actually before we do that, we need to offset. So we select the face, do Offset Entities, and the offset is 0.5. Hit reverse until you see the preview on the inside of the model. Then hit Apply. Now you could go to Features, Extrude Boss, and 1.12. Let me just verify that. That's 1.12. And we will hit the reverse switch for the extrusion depth and hit Apply. Now you could go ahead and select this face and start a sketch. Select the circle and make draw the circle tool. Put in the smart dimension. And if we look at that, the diameter here of that is going to be 3 inches. And then it's going to be a height of 1.62, which if we do the math quickly, it's just a ½ inch high from the last surface of 1.12. So type in 3 and go to Features, Extrude Boss, and 0.5. Hit Apply. Now we need to select this face once again. Start your sketch, take your circle tool, find the center here of this edge by gliding over the edge. Do not select it, it just highlights, and then it will highlight the center for you. Drag out your circle at that point. Go to Dimension and add your diameter dimension of 2 inches. And this is going to be 0.87, so basically 0.75 high. So 2 inches, go to Features, Extrude Boss, 0.75, and hit Apply. Now we could go ahead and add fillets. The fillets that are on here, the flange has a fillet callout of 0.125, and that should say for the entire flange. There should be a note there. There is not. So that's this fillet here. Everything else is a typical of 0.25. So be aware of that. That's a mistake on my part. So now we could go ahead and we have fillet selected, 0.125. Select this flange and hit Apply. Let's hit close there for a second. I think this is because I took the step of unfortunately putting the holes in before I should have. So let me clear out this. Let's see if we could just do an edge. There, we'll do that inside edge first. And let's go to fillet once again. Select this edge. Okay. Unfortunately, we weren't able to select the faces, and that's because of the edges of this hole would intersect with the other fillets. So we just have to be aware of that. Select the edges instead. Now go back to fillet, and everything else is 0.25. You can select this face, this edge, and that's it. Now what we want to do is let's go ahead and save what we have here. Good idea to do right now is go to File, Save As, and remember we're saving just the part document as a different name. Hit OK here, and this is going to be called the rear casting. Oops. Let me try that one more time. Okay, now what we want to do is, as long as we have that saved, we can hit save one more time, and this time select the assembly to save and hit OK, just to be sure that everything gets saved. So in the event that something crashes, you're in good shape because you can always bring it back. Now what we want to do is actually start working on the inside of this. So let's bring it outside of the assembly, and here's how. Just right click on any surface of it, if I could get it, right click, and you'll find open part. Here we want to go ahead and shell it. The typical wall thickness according to the print is 0.25, so select that face, go to shell, and select 0.25 and apply. Next, go ahead and start putting fillets. Typical fillets on the inside should be about 100 thousandths. And we probably want to cut this hole out. So select this face, start a sketch, draw a circle, make sure you wake up the center, draw a circle in there, and add the dimension. And in this case, according to the print, that diameter is supposed to be 1.447. And apply. Now go to Features and Extrude Cut. Select Through All. Okay, now we need to add the boss in the center here that will hold one of the bearings. So select that face, start a sketch, select the circle tool, and we will draw the inside diameter. In this case, according to the print, the inside diameter is 1.394. So go to Smart Dimension, 1.394. Hit Apply. And now here's the trick. Go to Features, Extrude Boss. It's going to be 0.75 high. No draft. Leave the draft off. The print does call out 3 degrees of draft, but it's not for the inside of this hole. Now what we need to do, there's supposed to be a 1/4 inch thickness to this, and this will actually be a hole instead. So we have to select this thin feature. Type in 0.25 for the wall thickness. And hit Apply. Go ahead and add a fillet. 100 thousandths. Actually undo that. I forgot. We have to add draft. I want to make sure you can add draft on here. So go to the draft tool. Select the neutral plane as the top surface of that boss. The faces to draft are the outside face. That's only. And 3 degrees. Make sure the arrow is pointing up. Hit Apply. Now you could go back and add the fillet. Now we need to add the ribs. The ribs are created using the rib tool. Select this face, start a sketch, take the line tool, and find an alignment line yourself horizontally and vertically through the inference lines and just draw short little lines. Just like you see here, floating in space there. Now they were actually in alignment vertically and horizontally. Now we could go to Features and select the Rib tool. The typical wall thickness is again 0.25. Add draft while you're extruding. Make sure you only have 1 decimal point. And 1 degree of draft. Draft outward and hit apply. Again, go to Fillet and add your fillets. Everything must be filleted. This is a manufacturing process and design class. When it comes to aluminum castings, everything needs a fillet on it, with the exception of this top edge here. That will be machined, and the inside edge. Okay, let's go ahead and save this. Now to return to your assembly, simply hold the Control key down and hit the Tab key 1 time. And you'll get the option, and you'll see where the assembly is in the part file. Make sure the assembly file is active and release. It says here, models contained within the assembly have been changed. Rebuild now. Yes. Okay, we're done with the rear casting. We could see it's still in blue. So again, a very important step here. Turn off Edit Component. Everything should be black now on the text, that is, on the feature tree. Now we could go glide up here and take care of the business with the bearing. So go ahead and select the mate. Select the surface of the bearing. If you can't, turn on Selection Filter with the X. And there we go. Select that face and this face. All right. We are done with the modeling of all the parts and pretty much the assembly here. Now what we want to do is we have to make an exploded view, and we have to do that in the assembly. We can't do it in the drawing. So here we go to Exploded View. Let's select the front here. It's actually not a bad idea probably to go to View Orientation, go to Isometric, and then grab the shaft of the rocket here, drag it forward, select the back part, the rear casting, select the shaft of the rocket, drag it backwards. Now you can select the 2 bearings in the front. You do not have to hold Control, just click on them and then drag. Click on the 2 bearings in the rear, drag it back, hit Apply. Now we need to add exploded lines to this. In the drawing it doesn't actually show that on the test, but I'd like you to try doing that. Go to Explode Line Sketch, select the edge here, make sure the arrow is pointing in the direction the line is supposed to extend to, and then select a radial edge here and hit Apply. You could do the same over here. If you select this edge, be aware the arrow will reverse by clicking on it, and then select this edge right here and hit Apply. Hit the green check mark, save. If you get a message like this, hit yes. And now we're ready to create our drawing. The last stage is to go to File, Make Drawing from Assembly, use a landscape so we could print it out, and proceed to grab the isometric view and drag it in from the left. Now just hit Apply and right click in the boundary of that view and you'll get the properties of that view. In the Properties dialog, select Show in Exploded State. Now let's make it a little bit larger. While it's still selected over on the left here, you could turn on Use Custom Scale and set it to, let's try a quarter scale. See how that looks. There we go. Now select the view, and we're going to start adding annotations. Under annotations here, click on that, and we're looking for tables. Click on the tables, and you will find, as long as the view is selected, meaning it has that blue box around it, you should, or green box, you can actually go ahead and select bill of materials. You could use Excel-based bill of materials, and in a setting where it's required perhaps to output an Excel-based bill of materials. In this case, we don't need to, so we'll just choose the standard one. Over on the left, you have options. Just hit apply, click, and drop it into the top left corner. It should automatically snap there. Now we want to add balloons to this view. Select the view, and you could go to auto balloon. And you have the ability to go with circular, top, square, bottom, left. I'm going to go with a circular pattern and grab one and drag it in a little bit, and then hit apply. Now you could rearrange these by grabbing the centers. Actually, grabbing the numbers will allow you to move them into position. Next step is to make sure that your name is on here. Go to Note, click where you want to drop it, and put your full name. And click somewhere on the screen to apply it. Click the green check mark. Now if we look at the midterm document, it's this one we were trying to recreate here. And as long as you have everything completed, you're good. So go ahead and save your document and print it out. Turn it into me, and that's it. And that concludes the manufacturing process and design midterm exam.